Using Tinkercad in mathematics courses could be a challenge, but again, it's that out of the box thinking that we need to bring into using these innovative tools. One project that I've done is where you create a model to scale. And in this case, I'm going to open up this design that is that of my home. And so this is a 3D model of my actual house. And it is to scale, where 1 millimeter equals a foot. And I'll show you in just a moment how to rescale objects, or how it can be used in math. But what I see here is an opportunity for math teachers to fully engage students, where the students can go home, get precise measurements of their home's width, length, height. You could get into pitch of the roof as well, depending on the level of class that you were teaching, or the type of student that you had in front of you, or the grade level. Many different exact measurements and to scale measurements that can be taken to incorporate new science math standards, where we deal with real life situations and math usage. And here you can see we have essentially many geometric shapes, three-dimensional, brought into a two-scale model and pieced together, just like a more complicated architecture or CAD drawing program would. But with Tinkercad, we're able to just simply bring in and drop these three-dimensional shapes. And if I don't like it, I can just delete it. But I can also change my scale. So if I need to adjust my grid, or I need to adjust my scale, I can do so down here with these tools. And if I go to Edit Grid, I can change the total size of the grid I'm working on. In this case, this would equal 200 feet, as I made 1 millimeter equal 1 foot. Or I could change the scale from metric to standard. Now, it will come up with an automatic default setting for particular 3D printers, but we don't need to worry about that. The nice thing is once I have that in place, I can then choose the amount I want to adjust at one time. So if I wanted to change things by 2 feet at a time or 2 millimeters at a time, I could do that as well. And this is very important, especially when it gets into geometry, where we try to help students understand the real-world application of the different bisecting and measurements of different degrees, angles, two-scale geometric models. You could even do a layout of just one room. You could start with a whole house or one room. You could design a football field or a stadium. You could design a swimming pool. I've had students sit down and watch them design and landscape a whole yard this way. Again, this allows similar content to be taught in an infinite number of ways based on your own students' need for engagement and what they're excited about and what they view as important at the time. For me, this was a good example of how I could show students how I used it in my own real life, as far as drawing an addition on my home here to the right in yellow compared to the original version, or the original drawing of the home, or sorry, the original portion of the home compared to the new addition of the home. So in this whole model, students can see how they can bring this into a real-world application. It's not just an assignment that they're doing in class. Again, this is just one application in math. I'm sure there are many. I could see designing whole amusement parks, or again, any personal engagement need of your students could be met, and get students excited and out of their textbook and into a real-world application of math.